All right, so today we are looking here at 2.3, and 2.3 is on the definition of trig functions. You're going to want to have out your 2.3 note sheet, and you're going to also want to have out the identity sheet that we're going to be able to take notes on as well. So I'm kind of going through some of this information here on our trig functions here. You can see we've got sine, cosine, tangent, cotangent, secant, and cosecant. And just remind ourselves what those relationships are. You saw this in Algebra 2 before. So on the unit circle, we know that our angle here is going to be, we're going to call it angle T here. So on our unit circle here, for instance, here at the ordered pair is the square root of 2 over 2 and the square root of 2 over 2 here at 45 degrees. So we know that the sine there of 45 degrees, it matches up with our y value on the unit circle. The sine of 45 there is the square root of 2 over 2 because it's our y value. And then the cosine of 45 degrees is also equal to square root of 2 over 2 because that's our x value there on our unit circle. But we also remember our trig functions here. So up here, I'm going to say the sine of t is equal to y on our unit circle, and the cosine of t is equal to x on the unit circle. But let's just go ahead and put in our SOHCAHTOA stuff here for these other values here, because that's going to become important later on. So looking here at sine here, remember sine is your opposite over your hypotenuse. And then we're going to label these according to our unit circle here. So according to our unit circle here, the sine here is equal to our opposite. So if I kind of draw out a triangle here, our opposite is over here, our adjacency here, and our hypotenuse is here. Well, our hypotenuse on the unit circle there is always 1. Our opposite here is equal to our y value, and our adjacent here is equal to our x value. So opposite here is y over 1, which gives us y. And cosine here is our adjacent over our hypotenuse, according to SOHCAHTOA there. And according to our triangle that we drew out over here, our adjacent there is x, and our hypotenuse up here is 1. So we end up getting the cosine is equal to x. The tangent, according to SOHCAHTOA there, is our opposite over our adjacent. And so our opposite side over here on this triangle over here, we can see it's opposite over adjacent there. It's our y over our x. So we're just going to leave it like that, y over x. Cotangent. Cotangent is just the reciprocal of the tangent. So we can either say 1 over the tangent, or if you look at your tangent there, it says tangent is equal to opposite over adjacent. If it's the reciprocal there, we can just flip that fraction and say it's adjacent over the opposite. And it's also the tangent is y over x. So our cotangent is just flipping that, and we get x over y. And then we got to look there at secant. Secant there is a reciprocal of the cosine there. So looking at that, I can say it's 1 over cosine t. T is just our angle, whatever that is. And so working with that now, we can look at our cosine there. It's adjacent over hypotenuse, so I can flip that and do the reciprocal. So it's hypotenuse over adjacent. And then it was just x, or x over 1, so now I can make that 1 over x. Cosecant is the reciprocal there of our sine there, so 1 over sine t. But sine there is opposite over hypotenuse, so I can just flip that fraction, and I can say hypotenuse over opposite. And looking up there at the sign there, it says it's 1 or y over 1, so that becomes 1 over y. So there we have our values there for the unit circle there. And kind of going back here, remember with our things with fractions here, you cannot get 0 down here in your denominator here. So x for tangent there cannot equal 0. And down here we can't get 0 there either, so we're going to say y cannot equal 0. And then for secant here, we got to say x cannot equal 0. If it does, then it's just undefined here. And then y down here cannot equal 0. Or does not exist, I guess we should say. Probably better. So next thing, we're just going to do a quick refresher. Well, on the top of your identity sheet that you have, that yellow sheet I passed out to you, you will see that at the top there, you've got cosine, sine, tangent, secant, and cosecant. Now it says theta on yours and mine say t's, but it's the same. It doesn't matter. It's just an angle measurement. So you're going to need to fill in that opposite over hypotenuse, adjacent over hypotenuse, and all the y's and the x's in there. You're going to want that on your identity yellow sheet there. So if you need to pause this video in order to fill that yellow sheet in, go ahead and do that. So moving on to this chart down there, you've also got a chart there on your identity sheet. We're going to start to fill in this chart here next. So doing our values on the chart there, I'm going to put some values up here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Just making sure I have. So this is my degrees, my radians, and I think you have enough boxes. 1, 2, 3, 4, 5, 6, 7. No, you don't. So you got to do the same thing on yours as well. So there's my degrees, radians. I'm going to do sine, cosine, tangent. And then I'm going to do cotangent, secant, and cosecant. And I'm just going to fill those in. So in degrees here, and we're all going to look at quadrant 1 right now. So I've got 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And then in our radians there, it's 0 degrees is 0 radians. 30 degrees there is pi over 6 for my radians. 45 degrees is pi over 4 for my radians. 60 there, we know that to be pi over 3. And then we know 90 there is just simply pi over 2 for our radians. So we've got all our radians and our degrees there filled in. Now you can just look at your ordered pairs there. So ordered pairs here for at 0 there. So at 0 there, my ordered pair there is 1, 0. So cosine's 1, sine is 0. My 30 degrees there, I'm going to go over the square root of 3 over 2, and I'm going to go up a half. So my cosine there ends up being square root of 3 over 2, 1/2. And then pi over 4 there is square root of 2 over 2, and square root of 2 over 2. Pi over 3 at 60 degrees, my cosine there is 1/2. My sine there is square root of 3 over 2. Pi over 2 there, we got our nice ordered pairs. It's 0, 1. Now let's figure out tangent. We said that tangent of whatever our angle there is equal to our sine over our cosine, which is really our y over x. And so we can take, for 0 degrees here, we can take 0 divided by 1. And 0 divided by 1 is just 0. For your sine there, we can go ahead and do 1/2. And we can divide that by the square root of 3 over 2. So now I'm looking there at that 30 degree one there. So really dividing is multiplying by the reciprocal. So I end up getting 1 over the square root of 3. But 1 over the square root of 3 there, I can't leave a square root of 3 down in my denominator. So I have to multiply my numerator and denominator by the square root of 3. So I get the square root of 3 over 3. Some of these are going to repeat after a while. So then 45 there. If I've got 45 there, if I take the tangent of my theta there is my sine, which is square root of 2 over 2, divided by square root of 2 over 2. Well, something divided by itself is just 1. And then 60 degrees there, I'm doing the tangent of that one. So doing a tangent of 45, or I'll write it out, tangent pi over 3 is equal to, we've got sine divided by cosine. So I'm going to do square root of 3 over 2 times the reciprocal, which is 2 over 1. So I end up just getting the square root of 3. And then I want to do the tangent of 90 degrees there. So tangent 90 degrees, or pi over 2, is sine over cosine. Cannot divide by 0. So this one here, we're going to say is undefined. Some people like to put a line here. Some people write undefined. Now, cotangent becomes easier since cotangent is your cosine of your sine here. It's just the reciprocal of what you have here. Well, the reciprocal of this would be 0 over 1, which would be 1 over 0. Well, 1 over 0, you'd be dividing by 0 here, so this one here, cotangent at 0 there, is undefined. So basically, we took, since cotangent at 0 is equal to cosine over sine, again, we cannot divide by 0, so we get undefined. 30 degrees there, we can take our cosine, oops, I'm going to do cotangent, is equal to my cosine divided by my sine, which is really square root of 3 over 2 times the reciprocal. So again, we get that square root of 3. And then, of course, cotangent here of 45, you take the square root of 2 divided by square root of 2. Something divided by itself is just 1. Cosine there, we've got that 1/2 divided by the square root of 3 over 2. Well, we did that down here already, 1/2 divided by the square root of 3 over 2, and we ended up getting the square root of 3 over 3. So I'm just going to rewrite it down instead of doing it again. And then I can go ahead and do cotangent of 90 degrees is equal to my cosine divided by my sine, which gives me 0. So we got secant and we've got cosecant here left. So I'm going to pause this video right now, and then I'm going to go ahead and go through secant and cosecant on the second video.